So this video is going to be algebra and trig review. I'm just going to go over a bunch of problems, and again, this is all prerequisite knowledge in order to go with the course. So I figured I'll go through a bunch of problems, because the more problems I go through, the better we're going to be equipped for calculus. And I'm just starting with some basic problems. Like for number 1, it says evaluate, basically find the value. And it has -3 to the 4th power with the parentheses. Part B has -3 to the 4th power, but it does not have the parentheses. And then part C has 3 to the -4 power. And so for A, -3 to the 4th power, because it's an even exponent, it becomes positive, and it would be positive 81. And that's because technically, if you want to write it all the way out, in our class we get to use calculators, but you could write it out as -3 times -3 times -3 times -3. That's what it means to be raised to the 4th power. It's multiplied to itself 4 times, which comes out to be 81. That's if you were to do it all the way through. But again, I'm fine with you just writing it. The answer is for something like this. And an important thing to know is that I have the parentheses. So whenever you have some quantity, let's say -x, to some exponent n, the negative sign goes away, and it's just x to the n if the exponent's an even exponent. Now, if it's odd, you keep the negative sign. It's -x to the n if n is odd. And that's because the even number of minus signs, they multiply out to give you positive. So like -3 to the 3rd power, that's an odd exponent. So my answer is going to be negative. And then that's going to be negative, I believe, 27. All right, now back to the problem. So part A, answer is 81. Now part B. So I have -3 to the 4th power and notice there's a minus sign, but there's no parentheses. When this is the case, this turns out to be actually -81. So you keep the negative if there's no parentheses. And that's because you can write this as -1 times 3 to the 4th power. 3 to the 4th power is 81. So this would be like -1 times 81, which would be -81. I'm not expecting to see all these steps, but that's the logic for why it's negative when you don't have the parentheses. All right, so anytime I just have -x to the n, keep the negative sign. Part C. So it's 3 to the -4. So you'd have to know rules with exponents. If you have a negative exponent, you would write this as 1/3 to the +4. And then that's going to be 1/81. So anytime I have a raised to the -n power, that's 1/a to the +n power. Similarly, if I had 1/a to the -n, that turns into a to the +n. So you either bring it to the numerator or bring it to the denominator and change the sign of the exponent. All right, now that's, so again, these are just basics. You keep going, so this will be part D. And let's say I had 5 to the 23rd divided by 5 to the 21st. Now you would just write this as 5 to the 23rd minus 21. That's 5 squared. So you get 25. Most people just do this in their head. You just subtract the top exponent minus the bottom exponent. Say I had 2/3 raised to the -2. So here's a trick. If I have a fraction raised to a negative exponent, you can flip the fraction. That turns into 3/2, and then change the negative exponent to a positive exponent. So that's going to be 3/2, so that's going to be 9/4. All right, so if I have a over b raised to some negative exponent n, I flip the fraction, so it's b over a raised to the positive n. All right, so I went ahead and wrote parts f and g. Now, the way I would do part f is anytime there's a negative exponent, I take care of that first. So I start inside the parentheses, and I would write this as 3x squared, but then I bring the y up top to the numerator and change that to a +3. All right, that's just a preference thing. Don't have to do it that way, but I tend to go ahead and make negative exponents positive. I don't like looking at negative numbers that much, or negative exponents. Now I sort of distribute this exponent too. And so I'm going to apply it to all the components. So I'm going to be applying it to the y, to the x, and then to the 3, and then also to the 7. If I'm going to do this consistently step by step, what this is going to turn into. So if I apply it to the 3, right, that's 3 squared. Now with the variable x, you multiply whenever it's a quantity that has an exponent raised to another exponent, you multiply the exponents. So it would be x to the 2 times 2, which 2 times 2 is 4. And the same thing with y, you do 3 times 2, so that's y to the 6, and then 7 to the 2nd power. All right, so that's a rule. If I have a to the m, and that whole quantity is raised to another exponent n, you multiply a to the m times n. Sort of, but the numbers like 3 and 7, you just distribute the exponent to be attached to it. So you have 3 to the 2nd power, which people will go ahead and just write that as 9. So it's going to be 9. And then x to the 4, y to the 6, and then 7 squared, that's 49. Okay, so for this one, we got 2 negative exponents. I'm going to first take care of this one. And again, if I have a fraction like a over b raised to some negative exponent, you flip the fraction. So it's b over a, and then change the sign of the exponent. So I'm going to flip this. So on the top now it's going to be x minus y. On the bottom it's going to be what I had before, 3x negative 3, x squared, and then y cubed. And then all of that's now to the +2. All right, and taking care of inside the parentheses, if I can simplify anything in here first, that's what I do. So I'm just saying simplify in the parentheses first. Now what I can do is I have an x to the negative 3rd and an x squared. They're being multiplied together, and when you multiply variables of the same, so they have the same base, x, you add the exponents. So up top, I have x minus y. And now I do x to the negative third, and then I do negative 3 plus 2 is negative 1. So that's x to the negative 1. And then y cubed, all of that squared. Again, so add the exponents when you're multiplying. Now this is where we're going to be careful. If I'm still working inside the parentheses, I'm going to make this negative 1 be turned into a positive 1 for the exponent. Well, since they're by the rule, I bring that to the top part. So it turns into x to the positive 1. But this is where you got to be careful, because the x minus y, this is treated as one quantity. And so I would put parentheses x minus y like that, because so I bring the x up top, and then I apply the x to the entire thing, x minus y. And then on the bottom now, I still have the 3. I got rid of the x, brought it up top, so then it's just 3y cubed on the bottom. And all of that squared. All right, now I'm going to worry about this exponent 2. So what I do, instead of distributing this x, I try to take care of this first. And then I just distribute the exponent 2 to all components inside. So it's going to be applied to the x minus y. Remember, that's one thing. And then the x to the first power, that's another thing. And then I distribute it to the y cubed. And then I also distribute the exponent 2 to the 3. So it'll be 3 squared. And I guess I can go ahead and drop the parentheses since I'm doing the exponent now. So x to the first power squared becomes x squared. And then x minus y, that's x minus y. That whole thing in parentheses, that's squared. And then on the bottom, I do 3 squared. And then y to the 3 times 2, I multiply the exponents. So that'd be y to the 6. Okay, and then you would multiply x minus y squared out. And on the bottom first, 3 squared is 9, so that's 9 y to the 6. Now so the algebra is prerequisite, but in algebra there's a formula that anytime you have a minus b squared, that turns into a squared minus 2ab plus b squared. Or you can do it as a minus b times a minus b and FOIL it. All right, but using the formula is just quicker. So for this x minus y squared, that's going to turn into x squared minus 2xy. And then plus y squared. All right, and finally, this would be the answer. Now you could distribute the x squared. The textbook probably would prefer something like this. Of course, on a test or a quiz or anything, I would accept it if you wrote it as x to the 4 minus 2x cubed y, and then plus x squared y squared. All right, that's another, it's the same thing. It's just I distributed the x squared now. All right, so I'm going to move on to a different type of algebra problem. So that was like number one. It had multiple parts, and then it's dealing with evaluating, just finding what it turns into after you apply some exponent. This would be number two. And I'm going to be factor the following. And I highly recommend you trying the problems first and then seeing how I do them. And if you know how to factor in a quicker fashion or a different technique and you get the same answer, that's okay too. Now for part A, you can use, so it's got the structure of difference of squares. And that's if you have a squared minus b squared, that factors into a minus b times a plus b. So that's a factoring formula, and it's got that structure. So for 4x squared minus 25, this will turn into 2x minus 5 times 2x plus 5. So you'd have to know that the difference of squares formula. Now for part B, notice there's a 2. So there's a number in front of the x squared. Anytime I have something of the structure like ax squared plus bx plus c, I use what's called, it's a factoring technique called AC method. And again, you don't, if you know another method, that's fine too. All right, and the way I demonstrate it, so we have 2x squared plus 5x minus 12. What you do is you multiply the first number 2 by the last number negative 12. So step 1 is multiply 2 times negative 12. So it's going to be negative 24. Step 2 is to find pair factors of negative 24. That they add together to give you the middle number, and the middle number 5 that add together. To give the middle coefficient 5. Well, negative 24, I know 8 times 3 is 24, so I can write this as 8 and negative 3, since 8 times negative 3 gives me that negative 24. And 8 minus 3 is 5. So what I'm going to do now for step 3 is replace the middle term, 5x, with 8x minus 3x. So the problem will turn into 2x squared plus 8x. So I'm writing it over again. I'm just changing the middle term. And then minus 3x. And then minus 12. All right, and the next thing, the last step, is to factor by grouping. And what I do is, so I'm just going to bring the problem down here. I group the first two terms together. So I group those two together, and then I group the last two terms together. And then for each group, I factor. So for 2x squared plus 8x, they share a common factor of 2x. And so what I get after I pull out 2x, that's going to be x plus 4. You can distribute the 2x. 2x times x is 2x squared. 2x times 4 is 8x. For the second group, they share minus 3. And you factor that out. That's going to also give you x plus 4. And this should always happen to where after you do this step, these two things are going to always match. So these need to match. And what you're going to do is factor that out. So factor out x plus 4. All right, so if I factor out x plus 4, what that leaves, what I'm left with, is going to be the 2x minus 3. All right, and this is going to be your answer. All right, that's doing the AC method. I kind of did it really step by step here. I'm going to do it real quick just to go over it again. And so I'll do it this time the same over again, but not writing step 1, step 2, like as detailed. The original problem was 2x squared plus 5x minus 12. And the first thing I did was I multiplied 2 times negative 12. So this is, again, I'm doing AC method, but just quicker. So I did 2 times negative 12. That's negative 24. Then I find what pair of factors give me negative 24 that when I add them together, I get 5. 8 times 3 is 24, but I can need 8 and negative 3, so 8 minus 3 gives me the middle number 5. So now I just replace the middle number. So instead of 5x, it's going to be plus 8x minus 3x. And then I still have the minus 12. And then I formed two groups. Now that I got 4 terms, I factor it by grouping. So I group the first two together, and then I group the last two together. The first group, I factored out 2x. And that gave me x plus 4. The second group, I factored out minus 3. That also gives me x plus 4. And then I saw that they have this x plus 4 in common. So if I factor out x plus 4, that leaves me with the 2x minus 3. All right, so I just did the same problem over again, but in less detail. That's how you do it using AC method. All right, then part C. So it's x cubed minus 3x squared minus 4x plus 12. Notice I have 4 terms. I'm going to factor it by grouping. So I'm going to group the first 2 together just to see what happens, and then I group the last 2 terms together. The first group, x cubed minus 3x squared, they share x squared. That's going to make this turn into x minus 3. The second group, I can have 2 possibilities. I could either factor out -4, or I could factor out +4. Now, if I factor out -4, what's that going to give me? So that makes this turn into x, 12 divided by -4, that's -3. So I know I went with the correct one because I have the x minus 3's. So I factor that out. So I have x minus 3 times, and I'm left with the x squared minus 4. And I'm not done yet because the x squared minus 4, this is a difference of squares. So this will turn into, so I have x minus 3, and then this turns into x minus 2 times x plus 2 after I apply difference of squares, the technique. So this will be my answer. All right, so that's number 2. This next one's going to be number 3. And again, I'm doing a bunch of random problems that are algebra problems right now that should be review of the skill set that you're expected to have. I think the more problems you do, the better. So I would search online for similar problems that I'm doing in this video to have more examples. This is number 3, and it's going to be rationalize and simplify. So I had 3 over the square root of 2. Rationalize just means to get rid of the square root in the denominator, if it's in the denominator. And I can get rid of the square root of 2 by multiplying top and bottom by square root of 2. So then I would have 3 square root of 2 up top. And square root of 2 times square root of 2 makes the square root go away. Since it's square root of 4, square root of 4 is 2. So it turns into just 2 now. And then that's what the result is after you rationalize. All right, so yeah, anytime the square root of a times square root of a, that just equals a. The square root sign goes away. Now something that's more complicated. So you had square root of 10 over square root of 5 minus square root of 2. All right, and to rationalize this, I have to use what's called the conjugate. And the conjugate, if I have a minus b, its conjugate is a plus b. And the why I would want this is because when you do a minus b times a plus b, the quantity multiplied by its conjugate, that's a squared minus b squared. So it's that difference of squares formula, but going in the reverse order. So for square root of 5 minus 2, so minus square root of 2, its conjugate is square root of 5 plus square root of 2. So when I do square root of 5 minus square root of 2 times square root of 5 plus the square root of 2, that turns into square root of 5 squared minus square root of 2 squared. And square and square root are opposite operations, so they cancel each other out. So that's just going to give you 5 minus 2, which we know is 3. All right, so that's what we're going to be doing. We're just going to multiply top and bottom by the conjugate. And so I multiply top and bottom by the conjugate of the bottom parts, square root of 5 plus square root of 2. And I did this stuff down here. So when I multiplied these two together, that gives me square root of 5 squared, makes the square root sign go away. So it gives me 5, and then minus the square root of 2 squared. And that gives me just minus 2 because the square root sign goes away. And up top, I'm just going to write it square root of 10 times parentheses square root of 5 plus square root of 2, just for now. So 5 minus 2 is 3. Yeah, now I'll just go ahead and distribute the square root of 10. You could have done it earlier. I'm just kind of doing it step by step here. Square root of 10 times square root of 5, that's going to be square root of 50 plus square root of 20. But then you can simplify square root of 50 and square root of 20. All right, so I would still simplify each one of these. I could simplify square root of 50 because 25 times 2 is 50. And you can take the square root of 25, that's 5. So really that's 5 square root of 2. All right, that's what the square root of 50 turns into. It's 5 square root of 2. Now the square root of 20, well, I know that's 4 times 5 is 20. You can take the square root of 4, that's 2. So that's going to be 2 square root of 5. All right, so this would be plus 2 square root of 5, and all of that's divided by 3. And that's the answer. That's what it is after you rationalize. All right, I'm going to do one more and make a part 2 to this algebra and trig review. So this would be like number, I guess part B to number 3. Or sorry, part C. All right, so this is square root of 4 plus h, and then minus 2 outside of the square root. And here, I'm going to rationalize top and bottom by the conjugate of this square root of 4 plus h minus 2. The conjugate of that, you just change the minus to a plus, and all of that, and I do that up top to the bottom. All right, I'm multiplying this out, and we know it turns into basically a squared minus b squared. So I'll do this sort of off to the side. So we know when we do a minus b times a plus b, that turns into a squared minus b squared. So in this case, you can think of your a as this whole thing, square root of 4 plus h, and then 2 is what b is. So it's going to be square root of 4 plus h squared, according to the formula, and then minus 2 squared. Now, what does that do? That gets rid of the square root sign. So really, it's 4 plus h minus 4. All right, so multiplying it by its conjugate, the square root of 4 plus h times itself makes the square root go away. So you just have 4 plus h, and then minus 2 squared, that's minus 4. All right, and on the bottom, I'm just going to leave it as h times square root of 4 plus h plus 2. I did not distribute the h yet, because you'll see in a second why I didn't do that yet. So 4 and minus 4. So that gives me h up top. And then h times the same thing on the bottom. And you'll see that I didn't distribute the h because I can divide h from top and bottom, which leaves me with the 1 up top. So this will equal 1 divided by the square root of 4 plus h, and then plus 2. Okay. And yeah, I'll do one more, and this will be number 4. So it's going to be solve. Now we're going to be solving the following equations. None of the questions I've been doing were equations. As far as the original part, question does not have an equal sign, whereas these, they're going to have an equal sign. So for instance, part A, so you had 2x over x plus 1 equal to 2x minus 1 divided by x. I'm going to make a comment. Before I try solving this, I know I can't have x be -1 or 0. So that's because of the x plus 1. If that were to equal 0, that gives me -1. And you can't divide by 0. So if you were to plug in -1, that'll be like -1 plus 1. which is 0. So you can't divide by 0. And then the other one's just x. So then it's just x equals 0. And these two values are called restricted values. Meaning you can't have these two as answers. So I'm saying cannot be valid for the answer or solution. All right, so I know I can't have x be -1 or 0, because if you plug those in, one of them you get 0 on the denominator. If you plug 0 on the other fraction in the denominator, you also get 0 in the denominator, and you can't divide by 0. So now I'm going to work out the problem. So that's something to know, is what do these denominators, what they can't be. All right, for solving this, I use cross multiplication. So I'm going to do 2x times x, and then I'll do x plus 1 times 2x minus 1. So that's going to give me x plus 1 times 2x minus 1, then equals 2x times x. That's 2x squared. All right, I just did cross multiplication. All right, that's anytime I have a fraction a over b equals c over d. You can cross multiply, and then it'll turn into a times d equal to b times c. All right, that's only when I have a fraction equaling another fraction that's valid. All right, so then this, I'm just going to FOIL it out. All right, so x times 2x, that's going to be 2x squared. Then I have x times minus 1, that's going to be minus x. Yeah, and then 1 times 2x, that's plus 2x. 1 times -1, that's -1. And that's equal to 2x squared. Notice I have 2x squared on both sides. If I subtract 2x squared, they cancel each other out. So you could really just ignore the 2x squares. They cancel each other out when you subtract 2x squared from both sides. All right, so -x plus 2x, that's going to be x. And then minus 1 equal to 0. So that means I have x is 1. And I got to check, was that one of my restrictions? No, it's not, because we had -1 and 0. So it's not one of my restrictions, so I'm good. This is the solution. All right. Now part B. All right, so I went ahead and wrote this out. So I have 2x squared plus 4x plus 1 equal to 0. And you'll find out that you can't actually factor this. So I know earlier I did some examples where I was factoring. So this one you can't factor. Now, if you don't really know how to factor for quadratic equations like this, you can always use this. The quadratic formula can always be applied. You don't necessarily need to know how to factor. I guess, like if your skill set for factoring is not so great, you could always resort to using this formula. All right, so if I apply the formula, so that's going to be x equal to, so again, my a is 2, b is 4, c is 1. So that's going to be -4 plus or minus the square root. You do 4 squared minus 4 times a, which is times 2, times c, which is 1. All of that divided by 2 times a, so that's 2 times 2. So 4 squared 16, so I have 16 minus, and then 4 times 2 is 8. So 16 minus 8, which gives me 8. And then divided by 4. And again, I did 4 squared 16 minus 4 times 2 times 1. 4 times 2 is 8. 8 times 1 is 8. So I have 16 minus 8, which turns into 8. All right, then you can simplify the square root of 8. All right, so it's be -4 plus or minus square root. 4 times 2 is 8. And you can take the square root of 4, it's 2. So it'd be 2 square root of 2 over 4. And there's a common factor that I can divide out. All right, so like, let's see, so I could divide out 2, for instance, or yeah, so if I divide out 2 from everything, 4 divided by 2 is 2. 4 divided by, again, 2 is 2, so that's a 2 down here. And then 2 divided by 2 is 1. So really, this is x equals -2 plus or minus the square root of 2, or sorry, plus or minus, yeah, square root of 2 over 2. All right, and technically you could have wrote a 1 here. I just ignore the 1 because it gets redundant to keep writing 1. And I have 2 possible solutions I can have. So one of them is -2 plus square root of 2 over 2. The other one's -2 minus square root of 2 over 2. So that's my 2 answers. And let's see. Or if you want to keep going, you could write this first one as -2 over 2 plus square root of 2 over 2, which that turns into -1 plus 1/2 square root of 2. And then the other one turns into -1/2 minus, or -1 minus 1/2 square root of 2. That's another possible solution, another way of writing the answer. So either are acceptable. Okay, I probably would go with the first one. Okay. All right, so I'll do one more. This will be part C. And again, I'm on, I think that was problem 4. Yeah, so these like solving type of problems. So this would be 4C. and it's 3 times the absolute value of x minus 4 equal to 10. All right, so one thing is you have to know for absolute value, you have the absolute value of u, that's equal to two scenarios. It's going to equal to u itself if the quantity is greater than or equal to 0, or it's going to equal to negative u if the quantity is u is less than 0. All right, so I'm going to use this definition in this problem. Before I apply that, I need to get this quantity, the x minus 4 quantity, by itself first. I can't just go directly into using the definition of absolute value. I need to get the absolute value quantity by itself. So by itself first, meaning I would divide both sides by 3. So that gives me the absolute value of x minus 4 equal to 10/3. And because of the absolute value, I'm going to have two scenarios. Because of this definition. So scenario 1, so you can think of the x minus 4, that's like my u. I could have that just equal 10/3 if x minus 4 is greater than or equal to 0. Or, again, my u is x minus 4, or I can have it as negative then x minus 4 equal to 10/3. X minus 4 is less than 0. So I have two possible scenarios for that. Now, if I went with each scenario, let's say I did the first one. I just add 4 to both sides to get x by itself. And that's going to be x equal to 4 and 10/3, which I would convert that into improper fraction. So that's 3 times 4 is 12. 12 plus 10, that's 22. So this would be 22/3. All right, that's the answer for scenario 1. Scenario 2. Now you could either divide both sides by -1 or distribute the minus sign. So it might be easier to just go ahead and divide by -1 so you can get rid of those minus signs. So then that's x minus 4 equal to -10/3. And then to get x by itself, still adding 4. And you're doing -10/3 plus 4. That's going to give me 2/3. All right, so I'll do that off to the side. So if I did -10/3 plus 4, right, you can write 4 as 4 over 1. But I need the same denominator of 3. So I multiply this top and bottom by 3. So that gives me 12 thirds. So really, it's negative 10 thirds plus 12 thirds, which gives me 2 thirds. All right, that's just the scratch work. For how I got the 2 thirds. All right, so two answers, 22 thirds and positive 2 thirds. And again, I used this definition. That's what absolute value is. I just, instead of u, I had x minus 4. All right, and that's where I had x minus 4 right here. My u is x minus 4, so that's greater than or equal to 0. And then negative, and then x minus 4, since u is x minus 4, and that's x minus 4 is less than 0. All right, that's why I had those two scenarios, just by using the definition of absolute value. All right, so that's where I'll stop it for this video. This went on a little bit longer than I was anticipating, but next video is a continuation of this algebra and trig review, which I'll get into some trigonometry in the next video. So continuation. Algebra and trig review.